Hello everyone, I am Divya from Department of MTech Computer Science and Engineering. Today I am going to explain a very interesting topic from communication engineering. It is called iPattern, a fundamental tool in communication engineering used for analyzing the quality of digital signals. First, let me define what an eye pattern is. An eye pattern, also called an eye diagram, is a graphical representation of digital signal obtained by overlapping multiple cycles of the signal waveform on an oscilloscope. The result looks like an eye, which is why it is called the eye pattern. On the horizontal axis, time is represented, and on the vertical axis, signal amplitude is shown. By overlapping many bits of the signal on the same time scale, engineers get a clear view of how clean or noisy the signal is. Now let's look at the key aspects of the eye pattern. First is the eye opening. This is the most important part. It is the clear space in the middle of eye. A wide and tall eye opening means the signal is strong and easy to interrupt. If the eye is open wide, the receiver can easily distinguish between ones and zeros, reducing the chance of bit errors. Now, if the eye starts to close either vertically or horizontally, this means the signal is degraded. Vertical closing indicates noise in the amplitude of the signal, while horizontal closing happens due to jitter or timing variations in the signal transition. For example, if jitter causes the signal to arrive slightly late or early, the eye will narrow horizontally, making it harder for the receiver to identify the correct sampling time. Another important aspect is the crossing points. The places where the signal transitions from low to high or high to low. Ideally, this point should be consistent. Variations here showing timing errors. The diagram in this assignment shows different eye patterns and under noise and jitter conditions. When the eye is fully open, this means low bit error rates and a reliable communication channel. If the eye is closing and errors increases, which is a problem in data transmission. Another interesting characteristics of eye patterns is their ability to reveal the effects of intersimple interference or ISI. ISI happens when signals from previous bits overlap with the current bit, causing confusion at the decision making stage. In the eye diagram, ISI causes the eye opening to shrink, leading to more overlap and higher chances of error. Eye diagrams are not just limited to one channel. Engineers often use them to compare the performance of different transmitters, receivers, or transmission media. For instance, if two cables produce different eye patterns for same signal, the cable with the wider eye opening is the better choice for high-speed communication. Eye pattern analysis also helps in diagnosing problems during system testing. For example, a noisy power supply can introduce extra noise into a signal, visible as a fuzzy eye diagram. Pinpointing these issues early helps avoid expensive troubleshooting later. It's worth noting in modern digital systems, automated instruments are often used to analyze eye patterns. These instruments provide measurements such as eye height, eye width, rise time, and fall time, which are key indicators of the signal. An example from real life is computer networking. When engineers that test Ethernet cables or fiber communications, they look at the eye pattern to ensure data can be transmitted reliably at high speeds. If the eye pattern is too close, data transfer may fail or become unreliable. Overall, by carefully analyzing the eye pattern, engineers can make informed decisions about hardware quality, system performance, and possible upgrades to their communication setups. Finally, let's briefly talk about the voltage thresholds and timing markers shown in the diagram. A threshold voltage helps decide whether a bit is 0 or 1 during sampling. The timing marker shows the ideal sampling point, usually in the middle of the eye. Sampling at the wrong time can cause errors. In summary, the eye pattern gives visual feedback about signal quality, jitter, noise and timing, enabling engineers to optimize communication system. Thank you for watching.